Hello everyone. In my previous video, I have explained you about non-clock NOR-based SR latch. Today, I will explain you clock NOR-based SR latch. So basically, this is a synchronous circuit. Therefore, the output will respond to the input levels only during the active period of clock pulse. Here, the clock that we have is a level sensitive, and this circuit will respond to the active high clock only. So, if there is a active low clock, that means clock is equal to 0, at that time the input signal have no influence upon the circuit response. That means output hold its current state. Now, if the clock is logic high, if it is a active high clock, then S and R input are permitted to reach the SR latch. Let us understand this thing with the help of this clock diagram. We have a clock signal over here. This is an active low and this is an active high. Now whenever we have an active low signal, the input have no influence on the output. But the moment we have an active high clock pulse, that means from this duration, if S is 0, R is 0, that means there is no change in the output, so Q will remain 0. But the moment we have S is equal to 1, that means we have a set state and we have a clock is high. So from this state the output will change and it will become high. Now it will remain high until there is a change in operation during a next high clock pulse or during within this particular clock pulse. So as there is no change in the input, it will remain high until there is a change in the next high active clock pulse. So again we have a 0 over here, so there is no influence of this thing onto the output and therefore the output will remain 1 over here. Now here we have again a active high clock pulse. Now S is 0 and R is 1. That means we have a reset operation over here. Reset means your output Q will now become 0. So therefore our output is 0 over here. Now here during the active high period, there is one more little pulse from S. So this S will trigger the output to the high and therefore the output will remain high till the next active high clock pulse. Now in the active high clock pulse, the S is 0 over here and R is 1 over here. So therefore again a reset operation and this will become 0. So this is how the synchronous, or we can say clock NOR-based SR latch is working. This is the circuit diagram of the clock NOR-based SR latch. Here we have a clock signal which should be an active high. So we are saying that this is active high and the value is 1. Now let us consider the first option, that is we have a input S and R we have as a 0 0. So S is 0, R is again 0 and therefore the output of this is 0 and again here it is again 0. So now if we are considering that previous operation have a value as a, let's say here it is a 0 and here it is a 1. So the 1 will be over here and 0 will be over here. So 0 NOR operation will 0, it result as a 1, 0 NOR operation with 1, it result as a 0. So that means our output will remain unchanged if the input is 0 0. Similarly, we can verify the 1 0 0 1 as well as the 1 1. So let us discuss about the 1 0 input. Here we have a S is 1, R is 0. We keep the clock as a 1. So therefore, this both value is 1 and the output will become 1 over here, and this both are 1, this is 1 and 0, so the output is 0 over here. Now the output of previous operation, that is Q, is 0, so 1 NOR operation with 0, it will result as a 0, and here we have a 1 as a previous operation and 0 as a current state, so 0 over here, and the output of current state is 0, so therefore the 0 NOR operation with 0 is result as a 1, and that's how during the set operation we have a 1 over here. Now let us discuss about the reset operation. So now we have a S as a 0, so we will consider a 0 over here. R is 1. Now we have S is equal to 0, R is equal to 1, clock is again 1, so we have 1 over here, and 0 AND operation with 1 will result in 0, 1 AND operation with 1, it will result in 1, and let's say here we have the 1, okay, which is a previous operation, and here we have a 0 again which is from the previous operation. So if we consider a 0 over here, that means we have a 0 and NOR operation with 1. So 0 NOR operation with 1 will result as output as a 0. Here if it is a 0, then 0 NOR operation with 0 will result as a 1. So therefore again during a reset operation the output of Q is 0. That means if R value is 1, the output of Q will become 0. That is a reset operation. Similarly, we can check the 1 1 also, which is not allowed in the SR latch. Clock NOR based CMOS SR latch circuit. So this is basically going to be a CMOS SR latch circuit. So in order to understand the CMOS circuit, you can refer my previous video in which I have explained you how to design the CMOS circuit. So here let us focus on this clock NOR based circuit. Here we have a 2 input S and R. Another input is clock. So in CMOS we have a 2 part, the NMOS and the complement PMOS. So we have a 2 AND gate over here. Let's say this is the 1 and this is the second. So here at the 1, S and the clock both are going to be in series in the NMOS. Similarly, as it is an AND gate, this R and the clock will be in series. Let us start with this second gate. I will draw first clock signal over here. So this is one of our input signal, clock, at the second gate. Another input is R, which will be in series. Now similarly, let us first draw S and the clock. So here we have a clock signal. This is a clock signal, and we have a S which is in series with the clock. This is the S. This all are the NMOS transistor. I am drawing the pull down network. Now after that, after completing all this point, we have a further next point is, let's say this is the A point, this is the B point. Here we have another input, that is a Q bar. Here we have a Q, it is a Q. So let's say this is 1 1 and 2 2 NOR gate. So in NOR operation, the NMOS will be in parallel. So A means this particular, these things. A means S and the clock, the series connection of S and clock. Similarly, B means series connection of R and clock. So as you can see, A is parallel with Q. So here we will draw one parallel NMOS transistor just like this. This is a parallel connection of, let's say this is a Q, and we will connect at this point. So this is the parallel connection, and we are just discussing the this point 2 2. Similarly here, this R and clock, they will be again in parallel with Q bar. So this is a B, and this is going to become a Q bar, and they are in parallel. So this is how we can design a pull down network for this circuit. Let us now focus on the pull up network, which will be a complement of this. So here first we will focus on the Q bar, which will be here we can see that R and clock, they are in series. So in pull up network they will be in parallel. R and clock, these both are in parallel with Q bar. So overall there will be a series connection. Let me draw and explain you. Let us first draw a Q bar. So let's say this is our Q bar. As it is a PMOS transistor, I will draw a bubble over here. So this is our Q bar. Now this Q bar is in series with parallel connection of R and clock. So we can draw as R is at this side, what we will do, we will draw a PMOS transistor for R at this side. So it will be easier for us. Just let me erase this. Okay, so here this is the R, which can be directly connected over here. Okay, and then parallel connection means we will draw a clock over here. So this is our clock signal. So now you can see that this R and clock, they are in parallel over here. Then this full combination is in series with the Q bar. So totally complement of NMOS will be over here, and we will connect this with a VDD. So this is your VDD. Okay. Similarly, we can draw for the this part also. So here first what we will do, we will draw a Q. So let me draw a Q in PMOS transistor. We can sort it over here. Now next what we will do, as and the clock as is at this side, so we will prefer to draw a S over here. So this is our S, and we will have a clock signal for PMOS. So this is our clock which can be directly sought over here. So we can say overall this is a clock signal. This is connected with the again VDD, and finally these two parallel connections are in series with the our Q. Okay, so that's it. We have almost complete the CMOS SR Latch circuit. We have already drawn the connection for the AND gate, NOR gate. Okay, similarly here also AND gate and NOR gate, but the last cross couple connection is remain. For cross couple connection, we have a one point, that is a Q over here. So let us say this is the Q, and which is connected to the Q is connected to the output of the R and the clock. So this particular Q is connected to the output point over here. So we will connect this Q point to the output of the R and clock. So this is one connection. Similarly, let's say we are talking about Q bar. So Q bar, which we have drawn over here, let me change the color. Q bar, which we have over here, is connected to the output of S and clock circuit. So here this is the output of the S and clock. So this is the output point, and this is the Q bar point which is connected over here. So this is how we can completely design the clock NOR based CMOS SR Latch circuit. So this is a clock NOR based CMOS SR Latch circuit. We have already designed this. Next, you can practice the SR Latch circuit. You can verify the which transistor is turned on and which transistor is turned off when we have a different kind of operation. Let me give you one example. Let's say we have S is equal to 0 and R is equal to 0. So during at that time, if S and R both are 0, this R value is 0, this S is again 0, we have a clock as a active high signal. This is 1. Okay, so at that time, if it is a 1 over here, then as this is the NMOS transistor, it will be a turn off. So you can say that this transistor will be turn off, this will be turn on, and it will be a short circuited. Okay, similarly this S is again a, as it is a 0, it will be a turn off, and clock it will be a turn off, turn on, and the short circuited. The complement will be over here. PMOS transistor will turn on whenever it will input as a logic 0. So at the gate we have a logic 0 over here and it will be a turn on, and we have a short circuit over here. The clock is 1 and it is a off, so we will say it is a off. Here again the clock is off. Here this is again a 1. Now in the previous operation, if we have the Q and Q bar value, let's say the Q is 1 and the Q bar is 0, of course it will be a complement. So if let's say Q is 1, that means this is our Q bar and this is our Q. So if Q is 1, then that means it will be a turn on and it is a short circuited. If Q bar value is 0, so Q bar value is 0, therefore this will be a off. Okay, and similarly here it will be as it is a 0, we have a 0 over here, we have a 1 for this. As this is the 0, it will be a turn on and a short circuited. Now at this side, as Q is 1, this is a off and it will be a open circuited. So we know that for the input S and R, if both are 0, the output will remain unchanged. Now you can see that this is a short circuited, this is the short circuited. So the output will be from this path, here, here and here. So this particular point is at logic 1. Here you can see that this is the off, so open circuited, and this is again off, open circuited. So this part will not be come into the picture. At this side we can say that this is off, this is on, but this particular transistor is off, so this full part will not come into the picture. But here we have this is on, as it is on, okay, and we have a path from this path, this here. So what will happen, this point will become now 0. So that's how you can see that the Q is 1 and the Q bar is 0. Similarly you can verify all other values. Thank you.